Okay, here's part one of a two-part video. We're going to take a look at the 2019 AP Calc question number 5. And we're going to go a little more in depth into just what's here, because this is a non-calculator question. I think they'll ask it more as a calculator question. I'm going to paraphrase the information that's here. They've given us a graph. They've given us a region that's enclosed between two curves. One is an upper curve and one is a lower curve. And they've given me an equation for each one. So with the calculator, it's really easy to graph and tell which one is the upper curve and which one is the lower curve. This was a no calculator question, but it's pretty obvious. If you look at this one right here, it's an x squared with a negative out in front. That means it's a sad parabola. That means this has to be the upper. That is h of x. And the lower curve is a cosine curve, which would make sense right here, is going to be this curve right here. This is going to be g of x. As a matter of fact, when I go to work on them, I'm going to label them in my according to the way I label my calculator. But the calculator part we'll do in the second part of the video. So before I specifically get into this problem right here, I'm just going to show you that whenever they give us two curves like this, the problem is going to be based on one of the following things. We're probably going to be looking for either area, which is either the integral of upper minus lower. We'll be doing a volume of rotation, which is our pi ya. You'll have all these formulas with you, so it's not going to be an issue. We don't have to memorize them right now. The pi ya, where A is the axis it wraparounds, Y is the upper, and the lower over there. And then there's going to be cross-sectional solids, but I'm going to put a star on this. This was the first test where they kind of tricked us on cross-sectional solids. But for the most part, cross-sectional solids are going to be some constant. That's the integral of s squared, where s is equal to upper minus lower. And they give us a number that goes out in front based on the shape that's going to be there. We'll worry those numbers at a later point in time. We're going to have them written. You're going to have your packet with them written down in it to begin with. And you can always remember that on a non-calculator problem or on a write-up problem, if you're not sure which is the upper and lower, you can always just put absolute value things on there to remove those upper and lower issues from the problem. But you're going to see they're going to end up being pretty much straightforward. So I'm going to move back to show you the two functions right here. And whenever I work on these problems, I'll label them as g of x and f of x, but on my paper, when I actually solve the problem, I'm going to label what I store them in the calculator. So I'm going to take g of x, I'm going to store that in f1 of x, and this is going to be f2 of x equals, I can now refer in the problem at any point in time to this function as that symbol, or this function as that symbol. If you don't want to do it, that's absolutely fine. It's just so I can match them up in my calculator as I'm going right there. So the very first question is, find the area of R. Area is just upper minus lower, upper minus lower. If we look back at the question, we need to know where the region starts and where the region ends. And we're moving along the x-axis, so we're going to be starting at x equals 0, moving to x equals 2, and the upper will be h of x minus the lower, which will be there. So this function is going to be, the area for it is going to be the integral from 0 to 2 of the upper curve, which for me is f2 of x minus f1 of x dx. Technically, I need parentheses here to make that problem all the way right. And in the non-calculator days, you'd have to work this one out manually. It's really not that hard to work out. We may work out another one in class at some point, but since it's not going to happen, we're not necessarily going to worry about it on the problem as we go right here. And we'll find that in our second video, which has our calculator portion in it as well. So we are going to skip for a moment to part C, because there's always going to be 3/4 of the problem is going to be straightforward. One thing is always going to have a trick on the problem. That's where we're going to get there. Just ask for the volume when generated around the line, the horizontal line, y equals 6. So if I were to look at this graph right here, the line y equals 6 is somewhere, let's look at the graph. There we go. The line y equals 6 is somewhere way up over here. But we're not going to pay any attention to any of that as we're going right now. We're going to do upper minus lower, upper minus lower, upper minus lower, and y minus a. Okay, so I'm going to move off this page for a second. And I'm going to work on this part of the problem right here. Volume when generated around y equals 6. So I know it's going to be the integral from 0 to 2 with a pi out in front, y minus a squared minus y minus a squared dx. So I'm going to first try to do it by figuring out upper and lower and filling all those things in. And then at the end, we'll just do it with the absolute value sign just to make sure it matches up. So when I actually go to solve this problem out, we know we got pi. We know we got 0 to 2. I know it's minus 6 squared minus 6 squared dx, because my axis is 6. The question is which is the upper curve and which is the lower curve. So let's do this the deep way, and then we'll do the easy way after that. I'm going to come back to the graph right here. If I were to wrap these two curves around that line in a big wrapping fashion, who would be the outside curve? Which curve would make the outside of the function? Outside is always the upper. So in this case, g of x is the upper curve, and h of x is the lower curve. So if I'm doing this problem without trying to get it exactly right, g of x is f1 of x minus f2 of x dx. And it's obviously different from the area problem, because when we rotate it, we get a different curve on the top. But if you don't want to do any of that, guess what? When you have your calculator, you don't have to. The correct answer, I could have put them in the opposite order. Wouldn't make a difference. f2 of x minus 6 squared minus f1 of x minus 6 squared dx. And the absolute value signs go inside there or outside. It doesn't make a difference. It'll give you the same answer either way. Okay, why did I save the middle part for last? Because it's the first time to kind of put the hard part in the middle. And I'm going to put the screen on here so we can read it for a second. It says the region R is the base of a solid. So, okay, I heard base of a solid. I heard cross-sectional solids. I'm just looking for the shape they're going to give me. For each solid, here comes the shape I'm looking for. Each of the cross-sectional sections perpendicular to the x-axis has the area of a of x equals 1 over x plus 3. Find the volume of the solid. I've never seen this question particularly before, but they didn't give me a shape, but they told me what the area of each cross-section was. So let's break this problem down how it works. If you don't get this, it's okay. You don't need it to get a 3 on the test, but anytime we're integrating, we're going up 1 unit. So basically, if I integrate the area of something times dx, it just means I'm taking some shape as an area, and I'm giving it a thickness, which is dx, and area times dx equals volume. So, although the problem seems weirdly worded, if I just integrate this curve from 0 to 2 of 1 over x plus 3 dx, that's going to find me the volume of the shape, because I'm integrating area. This is area times the thickness. It gives me that. So we can do that in the calculator. This one was a non-calculator question, so I'll just show you how it worked out. They wanted you to actually integrate this. And to integrate it, so it's the integral of 1 over something. The integral of 1 over something is the ln of that something, absolute value of that something. X plus 3 from 0 to 2. Should be ln of 5 minus the ln of 3, which would be the right answer for the problem for this one right here. Okay, so what we've done is we've looked really quickly. Area problem, upper minus lower. Cross-sectional solid, normally they give us a shape. In this case, they told me the area. If we're just integrating area, we get volume. And the third part, which is pretty straightforward, they asked me for the volume when rotated around the line y equals 6. I thought about the problem for a few minutes to figure out which is the outer or the upper curve and which is the lower curve. But because we have calculators, if we don't want to, we can just do the absolute value of each part. Okay, I think this is the type of question they may ask this way and make us do it in the calculator. I'm going to save this one right now, then I will turn to the calculator version, and we will talk about these problems on the calc and see what we get. Talk to you in a minute. Bye-bye.